Alright, hello everyone, and welcome to my session entitled Keeping Things Secret. Before I proceed, I'd like to mention that managing secrets is hard, and shout out to anyone managing secrets in production. Also, I'd like to thank the organizers for this opportunity. Thank you so much. So, who am I? I'm Jubril Oyetunji, a software engineer and a third-year student of cybersecurity. You can find me on GitHub or on Twitter at syntaxerror, and when I'm not coding, I'm probably playing video games or drinking coffee. First off, I'd like to talk about some of the challenges with secret management on Kubernetes. These are largely based off my experiences and also some of my observations from other people managing secrets. The first and probably the most obvious is that there's no encryption at rest, or probably any encryption at all. So, this poses a challenge because if your credentials or secrets get compromised, you're in deep trouble. Also, this is tied to my next point, which is committing encoder secrets into Git is all too easy. When you have a manifest and with some secrets in it, most times it's not encrypted, it's encoded. And if you're like me and you tend to forget things a lot, well, you're in deep trouble if you commit this if this makes its way into Git. This leaves you vulnerable, or just leaves your credentials exposed in general. The third would be RBAC for secrets. While you could argue that RBAC exists for secrets as RBAC covers API resources, I'd say it's not geared towards secrets, and secrets just happen to be an API resource. So where do we look? We look to the vault, not this vault, but HashiCorp's vault. So how can Vault help you with secrets? Well, a few ways. The first is encryption at rest, which tackles my first problem. Out of the box, Vault encrypts your credentials so that they are safe, even when they are compromised. But they shouldn't get compromised in the first place. Next would be access control out of the box. Vault provides a powerful means for doing access control management, which is really nice. The third would be third-party integration. Vault allows you to use third parties to do identity management. So if you're in AWS, Azure, or if you're using GitHub as an identity provider, Vault provides you a way to integrate this. The third would be dynamic secrets. Vault also provides you a way to dynamically generate credentials, and it can also manage them for you as well. Leasing and renewal is another big one I hear people say. So, while personally, I haven't really used this. It's a feature in case this is something you're looking out for. The final one would be injection, which is what I'll be demoing today. Vault allows you to inject secrets directly from Vault into your running application, which is really powerful if you don't like rewriting your whole application just to be able to use Vault. So, it's demo time. To save some time, I'd be walking you through a pre-recorded demo of me running Vault and injecting secrets into an application I've built. So first off, I have deployed Vault into my cluster, and it's running, and it's also unsealed. The cluster I'm using in this case is Minikube. Alright, so first off, I'm just going to be showing you what I have. If I do a kubectl get pod, you see I have one instance of Vault. This is because I'm running Vault in standalone mode, as well as the injector, which is essential for the next part, or later in this demo. So next, I'm going to enable Kubernetes auth. As you can see, I have already done it because it says here that the path is already in use. So Kubernetes auth enables Vault to be able to communicate with Kubernetes and do what Vault needs to do. But before I proceed, I would actually need to exec into one of the Vault pods to provide Kubernetes with the auth config, which is basically token, reviewer, JWT, and the Kubernetes host information. First, I'll need to log in, and I'm going to be grabbing my root token from down here. Again, my Vault is unsealed, so I stored my keys in the directory. So once I grab that, I'm able to log in, and Next, I can just write the Kubernetes alt config. To save time as well, I have already written out the command, also because I tend to forget it a lot. So yeah, once that's done, I can exit out of the pod and show you the cluster role binding. Basically, this is to provide Vault with a service account and give that service account a cluster role binding. In this case, it's system auth delegator. This is because Vault needs some elevated privileges to function. Once that's done, I can apply this to my cluster. Because I've done this already, the resources are unchanged. Next is the policy. Basically, a policy allows you to tell Vault what a particular app or role is allowed to do. In this case, the capabilities are read and list, and that would be for the path apps data guardian. Guardian is the name of the app I will be deploying, so I place it under the path apps data guardian. Once it's done, I can use the Vault CLI to write this to Vault, and that should get uploaded. All right. Next, you'd want to write create a role for the Guardian app. So in this case, I'm placing down the path auth Kubernetes role Guardian. The field bound service account names basically tells Vault what service account is going to be operating under the role Guardian. In this case, I've named it Guardian SA, and the service account namespaces this role will be bound to is the default namespace. Also, if you remember the policy I deployed earlier, it's called Guardian RO. So I'm specifying that here, and the TTL of 24 hours. Once that's done, you can write this to Vault. And now I'll be showing you the manifest. Like I mentioned, the name of the app I'll be deploying is Guardian, and Guardian is a very secure app which shows you credentials that it has in Vault, or it has obtained from Vault. This is because it's looking for a specific text file that Vault would inject into the pod, and so it's able to pick up credentials from there. And remember the service account I mentioned earlier, it's defined down here as Guardian SA. Alright, so you can apply that and the app gets created. I'm going to port forward the app so I can access it from localhost. Okay, alright. So at this point, if you try to curl the secrets endpoint, the app is going to tell you that it holds no secrets. This is because the text file in which it looks for secrets is not available to it. Therefore, secrets cannot be found. So to solve this, you would first need to enable the Vault key value store, which is what I've been using to pass in secrets into Vault. And the path I'll be using is apps, and I'm using version 2 of the Vault key value store. Once again, I have enabled this in some earlier testing, so it says the path is already in use. Next, I'm going to be writing a message to the app, which is the Guardian message and Guardian encryption key. These are just arbitrary values that I can switch around, so I would proceed to write this as well, and I get some information back. And now I'll be updating the manifest with a few differences. So first is the annotations. This is probably the most important part. First, I'm enabling Vault agent inject. The way Vault injects secrets into your application is by running a sidecar in the same pod, and this pod will be able to pass the secrets from Vault into your application. Next, I'm telling Vault what role this app is going to be using, and in this case, it's the Guardian role we created earlier. And I'm telling Vault to look under apps data guardian for the secrets. If you remember, I put this in key value store earlier, so that's the path that Vault will look for secrets in. And here's the really cool part. This template annotation allows you to specify the format in which you want your secrets to look. In this case, I'm using basically a column to separate the individual values. So that's what you get here. Besides that, nothing really changed. The service account and service stays the same. So once you're done, you can easily write this out and apply it. So the only thing that gets changed is the app itself. At this point, if you try to call a secret endpoint, it says there's an empty reply. This is because Vault would actually have to restart. Would have to inject the pod, so which would lead to a restart. So now I'm going to port forward the service again, and if you look at the output, it says Guardian has already found some secrets for us, and it prints them out here. So that's it for the demo. So thank you so much for attending my talk. I hope I've been able to show you some of the powerful features that Vault provides. In this case, it's just the application secret injection, which is something I found really useful, because if your application is trying to look for secrets and you don't need to make Vault aware of anything. Your application doesn't need to be aware of the secrets or the existence of Vault. All it knows is where to look for the secrets, and Vault just handles the rest. Once again, thank you very much for attending my talk, and thank you to the organizers for having me.